Welcome to Quantixy, where we explore the universe's deepest mysteries. Today, we'll uncover the secrets of black holes, the nature of space and time, and the mind-bending laws of quantum physics. Get ready to see reality like never before. A black hole is the only place in the universe where the laws of physics officially give up. You can't see inside it. You can't escape it. And if you fall in, no information ever comes back. So today, we're re-asking the most dangerous question in astrophysics. What is actually inside a black hole? First, let's clear something up. A black hole is not a hole. It's not a tunnel through space. And it's definitely not a cosmic vacuum cleaner, endlessly sucking up the universe. A black hole is a region of space where gravity becomes so intense that the laws of physics begin to break down. So intense that even light traveling at nearly 300,000 kilometers per second cannot escape. Once it crosses a boundary called the event horizon, black holes don't roam the cosmos hunting planets. They form when massive stars collapse under their own gravity, compressing an enormous amount of mass into an incredibly small volume. Here's something that sounds impossible, but it's true. If the sun suddenly turned into a black hole with the same mass, Earth would continue orbiting it almost exactly the same way. The gravity would be identical. We wouldn't get pulled in. We wouldn't spiral into darkness. We wouldn't be destroyed by gravity. But we would freeze. Without sunlight, Earth's temperature would plummet. Oceans would slowly ice over. Life as we know it would struggle to survive. Black holes aren't monsters tearing through space. They obey the same gravitational rules as everything else, just pushed to an extreme limit. They don't destroy reality everywhere. They reveal where reality reaches its breaking point. Black holes aren't holes in space. They are reminders of how powerful gravity truly is and how fragile our understanding of the universe really remains. Every black hole has a boundary, a point of no return. It's called the event horizon. Cross this invisible line and escape becomes impossible. No rocket, no signal. Not even light can ever leave. From the outside, something strange happens. As you fall closer to the event horizon, time itself begins to slow down. Your motion appears to freeze. Second by second, you seem suspended, hovering at the edge forever. To a distant observer, you never truly cross the boundary. You fade. Redshifted, stretched by gravity, frozen in time. But from your own perspective, nothing feels frozen. You fall straight in. Your clock ticks normally. Your heartbeat stays steady. Space pulls you forward, and there is no sudden wall, no dramatic moment, no visible line in space. Physics can still describe what happens up to this point. Einstein's equations work perfectly here. They predict the bending of light, the slowing of time, and the unstoppable pull of gravity. But beyond the event horizon, our equations begin to fail. Inside, space and time trade roles. Moving forward in time becomes as unavoidable as falling downward. The center, the singularities, no longer a place you can avoid. And this is where things get uncomfortable. Density becomes infinite. Curvature becomes infinite. The known laws of physics break down completely. We don't know what truly happens next. Not because it's hidden, but because reality itself stops making sense. The event horizon isn't just the edge of a black hole. It's the edge of our understanding. What happens when you fall into a black hole? Well, it's not a gentle journey. Gravity doesn't just pull you in, stretches you. The effect is so extreme that scientists have a special name for it: spaghettification. And yes, it's exactly like the pasta. Imagine your feet getting pulled with way more force than your head. Every single part of you is being stretched, elongated, and torn apart. Individual atoms start to stretch. Molecules break. The very fabric of your body unravels. You're no longer a single object. At this point, biology doesn't even matter anymore. Life as we know it simply stops. Time and space warp around you, and the known laws of physics start to break down. This is where our understanding fails, and the raw, terrifying power of gravity takes over. A black hole doesn't just eat things. It transforms and destroys them in ways our minds can't even begin to imagine. At the center of a black hole lies something truly strange. It's called a singularity, a point with infinite density, a point with zero volume, a place where our mathematics simply stops working. Every known law of physics collapses here. General relativity fails, quantum mechanics struggles, and even it can't make sense of what's happening. It's a region where time, space, and matter lose all meaning, where cause and effect break down and reality itself becomes uncertain. Scientists study it, calculate it, and theorize about it, but no one truly knows what happens inside a singularity. And, remarkably, they're honest about that. The singularity is more than a mystery. It's the ultimate boundary of human understanding, a place where the universe reveals just how much we have yet to learn. Have you ever wondered what would happen if you fell into a black hole? The answer is stranger than you can imagine. Inside the event horizon, the very laws of reality as we know them get flipped on their head. Time and space literally switch roles. Think about it. Right now, you can move freely through space left, right up, or down. But you're stuck moving forward in time, second by second. Inside a black hole, it's the opposite. Suddenly, moving toward the center, the singularity becomes as unavoidable as the future. You can't stop it, you can't turn back. Every single moment pulls you deeper, just as tomorrow always arrives. From the outside, an observer would see you frozen at the edge, stretched and slowed for eternity. But for you, the journey continues. You are on a one-way trip, not just through space, but through the very fabric of space-time itself. This radical twist makes black holes the ultimate, most extreme time machines in the universe. A place where the concepts of past, present, and future completely break down. It's a journey to the end of everything, with no escape. Have you ever wondered what really happens to information that falls into a black hole? Here's the problem that keeps physicists awake at night, according to the laws of quantum mechanics. Information can never be destroyed. Every particle, every quantum state leaves a trace somewhere in the universe. Nothing is ever truly lost, but black holes. Black holes seem to break this fundamental rule. Anything that crosses the event horizon, the point of no return's thought to vanish completely. Stars, dust, even light itself. And if the information about those particles disappears along with it, that contradicts one of the deepest principles of physics. This contradiction is known as the black hole information paradox, and it's one of the most puzzling mysteries in modern science. It's more than just a thought experiment solving, it could reveal how gravity and quantum mechanics truly interact, potentially giving us the keys to a theory of everything. Imagine a universe where the tiniest pieces of information are never truly gone, even in the face of a black hole's immense gravity. Scientists are exploring radical ideas, from holographic universes to the notion that black holes might slowly leak information back into the cosmos. Every theory challenges our understanding of reality itself. Some even suggest that black holes are not the cosmic trash bins we once thought, but sophisticated information-preserving engines. The information isn't destroyed, just hidden, encoded in ways we've yet to fully comprehend. The paradox doesn't just affect black holes. It touches the very fabric of space, time, and the universe's ultimate fate. Physicists are still debating, experimenting, and calculating, hoping to uncover the answer. And when they do, it could transform the way we understand everything from the tiniest particles to the vast cosmos. The black hole information paradox reminds us that the universe is stranger, more mysterious, and more beautiful than we can imagine. And one day, maybe, we'll finally unlock the secrets hidden behind that darkness. Have you ever looked up at the stars and thought black holes might be even stranger than we imagine? Forget just being cosmic vacuum cleaners. Some cutting-edge theories suggest black holes aren't just empty voids at all. One mind-bending idea is that they have holographic surfaces. Picture this: all the information about every single thing that has ever fallen into a black hole, stars, planets, you name it, isn't lost forever. Instead, it's encoded on its outer boundary, the event horizon. It is as if our three-dimensional universe is being projected from a two-dimensional surface, like a cosmic hologram. Then there's the quantum firewall theory. This proposes an invisible, unimaginably energetic wall of fire right at the edge of a black hole. Anything that tries to cross it would be instantly vaporized. It sounds like something straight out of science fiction, but physicists are seriously debating whether these firewalls are real. And what if black holes aren't the ultimate dead ends? Some theories suggest they could be wormholes, tunnels connecting to distant parts of our universe, or maybe even to other universes entirely. Instead of a one-way trip to oblivion, they could be gateways to the unknown. These aren't just wild guesses. They are serious physics debates, explored with complex equations and quantum theories. Each idea pushes the boundaries of what we know about reality, gravity, and information itself. So what are black holes, really? Cosmic archivists, burning walls, or bridges to another world? The universe holds its secrets tightly, but we're getting closer to the answers every day. How do you study something you can't see? I mean, really can't see, ever? That's the huge challenge scientists face with black holes. You see, nothing, not even light, can escape a black hole once it crosses a point of no return called the event horizon. This means we can't send a probe inside to take a look and send back pictures. Any camera, any sensor, any signal would be trapped forever. Communication with the outside universe is completely severed. So, if we can't look inside, how do we know so much about them? It all comes down to being clever cosmic detectives. Everything we've learned about black holes comes from the outside. We start with the language of the universe, mathematics. Physicists use complex equations to predict how matter and energy should behave under the crushing force of extreme gravity. Then, they build powerful computer simulations to visualize these predictions. The next step is to look for clues in the real universe. We can't see the black hole itself, but we can see its effects on everything around it. Think of it like a locked room in the middle of nature. We can't open the door, but we can study the shadows it casts. We watch for stars orbiting what looks like an empty patch of space. We observe how light from distant galaxies gets bent and distorted as it passes by a massive, invisible object. And with incredible instruments, we can even detect gravitational waves, tiny ripples in the fabric of space-time itself, sent out when two black holes collide. When what our telescopes and detectors see matches what the math and simulations predicted, we know we're on the right track. Each observation is another clue. Every orbiting star, every warped beam of light, and every gravitational ripple helps us piece together the puzzle of what's happening beyond the event horizon. It's one of the greatest challenges in all of science, understanding an object that hides its true self completely, yet using nothing but logic, equations, and observation. We are slowly unlocking the universe's most tightly sealed mystery. Understanding black holes isn't about destruction. It's about understanding reality at its deepest level. These objects push the laws of physics to their limits, forcing us to question everything we think we know about the universe. Inside a black hole may lie the answers to some of the biggest questions science has ever asked. How did space itself begin? Why does time flow the way it does? And does the universe have an ultimate boundary, or does it extend forever? Black holes bring together gravity, quantum mechanics, space, and time in the most extreme conditions possible. By studying them, physicists test ideas that can't be explored anywhere else in nature. Every equation, every observation brings us closer to a deeper truth about existence itself. Black holes aren't the end of knowledge. They're the challenge that pushes human understanding forward, inviting us to explore the deepest structure of reality and rethink what the universe truly is. Black holes aren't about destruction. They're about understanding reality at its deepest level. They challenge how space began, how time truly works, and whether the universe has limits at all. Like and subscribe to Quantasy, and watch more if you want to explore advanced quantum physics and the mysteries that push science to its edge.